Continuing with our different types of forces, or different types of force problems that we're working with in grade 12 physics here at James M. Hill. This is the second type where we're hanging an object and we're working on how the force of tension breaks apart into its components of that object. So here's our example from our worksheet. Traffic light is to be hung like in the diagram to the right. Both angles are the same, very important. The cable being used will break if their tensions reach 2100 newtons. What is the smallest angle that can be made if the lights have a mass of 150 kilograms? So we're trying to figure out angle here, and it's angle for a very specific force of tension within these lines, and that's if the force of tension reaches 2100. Now that's not combined, that's each cable can maintain or withstand 2100 newtons of force. So that 2100 newtons, it's not real obvious, but it's very important is that 2100 will break up to a component horizontally and vertically. And that angle between those components is the angle theta that we're trying to solve for. So if we can figure out what are the x components or the y component, we can then work backwards with our trigonometry and figure out the angle. The key here is that you're given the mass. That means you're given the force of gravity. Because force of gravity is mass times acceleration of gravity. So since you're given the force of gravity, now we can figure out what the upward component is, knowing that the other rope or other wire, whichever it is, also breaks up. So we're just going to call this Ty on either side, tension in the y direction. If you want to label everything, there's your tension in the x direction. So both of those upward components of the tension, Ty, have to add to counteract the force of gravity downwards, Fg. And therein lies the key to the whole problem. So once again, it starts as our net force. It's the sum of all forces in a particular direction. In this case, we're working with y direction. Well, the net force in the y direction is the force of gravity plus the component of tension from each wire or each rope. That's very important that there's two there, not just one. Okay, because each wire does half of that force of gravity's, or half of the mass's weight. Net force is 0, it's not moving anywhere. Force of gravity we have, that's negative mg, it's 115 kilograms. Gravity is 9.81. Don't put gravity as a negative 9.81, just leave the negative out in front. Before I go further, that's 110 kilograms, not 115. And the two Ty's we don't know, but we can combine those to say 2Ty. So now we solve for Ty, force of tension in the y direction, or vertical direction. So just rearranging and multiplying the numbers out gives us 1079.1 on the left, has to equal 2Ty. Divide both sides by 2. The upward component of the tension is 540 newtons. It rounds to about that anyway. Remember, that's not our answer. That is the amount of weight each wire supports. So that's our Ty. Now we have hypotenuse of that triangle. We have opposite side, so we can figure out the angle. So the sine of the angle in question is opposite, Ty, over hypotenuse, which is the full force of tension. Remember, that's 2100. So just rearranging for Ty, it's going to be the magnitude of the tension, sine of the angle. So 2100. Sorry, recheck this. We're not solving for Ty, we're solving for sine of the angle, which is exactly in the formula that I have. Ty is 540. Tension is 2100. Both are newtons, and both units will divide out. So sine of the angle works out to be, divide that by 2100, 0.2569. When you're finding angles, make sure you always keep at least 4 decimal places. So the angle is going to be the inverse sine of that, or the arc sine. depending on what they're teaching you down the hall. And that works out to be about 15 degrees. So remember, we break up our force of tension into components to visualize the problem. Those two components have to counteract the force of gravity of the sign. So that's my starting point. I do the net force in the y direction, figure out my upward component of tension, then I go to my trigonometry and figure out what my angle is using opposite over hypotenuse as sine.